Decode.map is something we're using in quite a few places in the code base. So one example of it is the one that we saw earlier, where we needed to translate the body into a full body on the article. So this is an example of using decode.map to essentially wrap a value that we're getting as one of our fields in some other type. So the purpose of this was that we have two notions of article. We have article full and we have article preview. And in this case, when we're decoding a preview, we want to hard code it and say, yeah, we're not going to look for any additional info on there. It's just a preview. There's no body associated with it, so don't worry about it. And in this case, we want to say we have an article full, and we use decode.map to say, not only do I want to decode the body, which is to say this body decoder, but once that's done, I want to, if it's successful, transform that success value by wrapping it in this full value right here. And full is defined like this, so it's a function that takes a body and returns a full value. Okay, so that's one example. Another pretty common example we can see in this right here. So here we have a comment. Comment, like so many other types in our program, is opaque, and it looks like this. This is a pretty common strategy that I like to use for representing opaque types while still getting access to the nice record constructor for decoding purposes. So I'll define a type alias called internals. That represents the record that I can work with internally to this module. I don't ever expose it to the outside world, and then I can use it for JSON decoding. So I have comment, which has one variant, and its sole variant has one argument, which is internals. As previously discussed, in terms of runtime representation, that means that because it's a single variant with a single value inside of it, Elm's going to unbox this, and at runtime, this is just going to be as if I'd used a record, plain and with no wrapper around it. But for compile time purposes, I do actually need to specify that wrapping. So when I'm using this internals decoder, I'm essentially writing as if I had used this as my fundamental data type. I say, yeah, I'm going to decode into this. It's going to follow the same pathway that we saw on the slides. We're going to require this, which is going to be the first argument to that function. This will be the second. This will be the third. This will be the fourth. And then once those are done, we know now, after having gone through those slides, this expression will evaluate to a decoder internals. But that's not what we want. What we want is a decoder comment. And in order to map it to a comment, we can just take this expression right here and say, once we're done decoding into internals, just wrap it in a comment. No problem. And that's all there is to it. This is a pretty common way of translating, sort of getting the best of both worlds, getting to use the record constructor internally for convenience while still exposing an opaque type to the outside world for our decoder. So, to recap, we talked about pipeline types and how those work. We talked about decode.andThen. We talked about decoderizing, so that's with the ISO 8601, we sort of decoderized that from a result into a decoder by using decode.andThen. And finally, we talked about intermediate representation, so the idea of using internals only for the purpose of creating a decoder, not exposing it to the outside world, and just using that as an intermediate step, and then using decode.map to convert from that intermediate representation into the one that the outside world actually sees. One more note on intermediate representations is that if you want, you can take that a few steps further and use it with decode.andThen or something else to decode into some record that kind of has no relation to what the final representation is going to be, but which just gets it into a record so you can work with it more nicely in your Elm logic if you have some complicated and then code or something like that to work on.